topic of pesticides, and this is obviously an issue that we could spend the whole day on, and I've got 25 minutes to talk about the topic. So what I'm going to do out of necessity is I'm going to make this a very general presentation. A lot of you are very familiar with what's out there in the literature. But my hope is that as I cover this material, there's one or two nuggets of insight that are new to you, and it will lead to a nice discussion when we get to that portion of the program. The discussion really today is all about movement of chemicals to water. In my case, it's with pesticides, and you know, as we picked up over the course of the day, it really comes down to two primary processes and one additional factor, and that is mobility, persistence, and load. Those are the three things that we're going to really simplify it down to three items. In terms of pesticides, there's two things that are going to modify it. It's going to be the chemical property of the pesticide, and it's going to be the environment in which that pesticide is placed. What I'm going to focus on my talk today is I'm really going to focus on the environment side. What's unique about turf, or what does turf have in it as a system that makes it advantageous if you're going to go ahead and apply a pesticide to a turf site from an environmental perspective. Okay, so we've seen a couple different shots of this earlier. Turf grass usually comes in two forms, with or without the presence of a thatch layer. With the thatch layer, you have three layers, basically, that are important in terms of attenuating the movement of a pesticide. Foliar layer, thatch layer, and then a third layer. You're going to break the soil up into two components, within the root zone and out of the root zone. I'm only going to talk about the root zone portion of the turf grass canopy. Okay, so if you look at the foliar layer, that's the first barrier. The first primary barrier is the downward movement of the pesticide. And if you look at the processes that can occur within the foliar layer, there are several processes that can occur that are going to lead to increased or enhanced dissipation of the pesticide when it hangs up or gets intercepted by the foliar layer. And that's usually going to be the case with our foliar applied pesticides. Those that are susceptible to reactions with sunlight, this process is definitely going to be enhanced versus having that pesticide move down into the soil a centimeter or two. As the pesticide is absorbed on the leaf foliage, it's going to be rapidly metabolized, and that's going to lead to rapid rates of dissipation. And then the process of volatilization, that's primarily driven by the vapor pressure of the pesticide in combination with its water solubility. And there's really not much information out there if you look in the literature about comparing turf grass stands volatilization versus bare soil. But if you look in the ag literature, what they see is that when a pesticide ends up on the foliage of eggplant, it dissipates more quickly than it does from the soil surface. And what it's been attributed to are two things. One is primarily that the temperature of the foliage is higher than the soil if you have it down an inch or so. And I don't know if I buy into that idea totally, because in the case of what we've seen data earlier today, in the turf grass situation, you have usually a cooler surface than you do at the soil surface. But what we do see in turf grass in heat studies is if you go to the top portion of the canopy, the aerodynamics of what's going on in that portion of the canopy is much more, the flow is much more turbulent, particularly as the turf grass starts to grow up in height. And that turbulence gives vertical lift, the movement, dissipation of pesticide through the process of volatilization. So that second process is definitely in agreement with what we've seen in turf and heat data. The first one is an open question. It's really something we need to look into a little further. Interestingly enough, there's a PhD dissertation that was completed back in, just after 2000 at Purdue University. And they looked at microbial degradation of pesticides on the foliar surface. And one of the things they pointed out in their paper was, first of all, that if you look on a per gram basis, the number of microorganisms that are present on the foliage is about the same as what you're going to see within the soil. However, if you go and look at pesticides that are fairly mobile, these are ones that do not absorb readily on foliage, it takes a fairly long time for them to get tightly absorbed. What you see in general is that for about the first 24 hours, that you can extract all that material back off. And the author indicated that during this period of time, that pesticide should be metabolized by microorganisms. But once you got past that first 24 hours, and these are three fungicides, not things that we're going to use in home lawn situations, but the main thing is to focus on the KOC. Once you got past that first 24 hours, you saw that it rapidly became irreversibly bound. And what that means is that the microorganisms can't utilize that. So in terms of microbial degradation of a pesticide on foliage, his contention is that that's really a process that's limited to about the first 24 hours. After that, it's not a significant process in dissipation of pesticides from foliage. One of the other advantages, obviously, this has been alluded to by several people, is that when you're talking about a turf grass situation, you've got foliar cover, you shut down one of the primary ways that you can lose the chemicals in the environment, and that's through entrainment. So the pesticides attached to soil particles. You just had a talk on phosphorus. That can be one of the primary modes in agriculture. Well, it can also be one of the primary modes for pesticides that have very high KOCs. So by having that full turf cover, you're going to have very little soil move off. This gives you an appreciation for how much soil does move off from a turf grass site. This is a study that we've been involved in for a number of years, and that's looking at runoff of pesticides and nutrients from creeping paintgrass turf. This is a very large plot, 5,000 square feet, so it's essentially the size of a home lawn. What we do is we apply rain at a rate of 1.4 inches per hour for the time needed to have runoff occur plus 90 additional minutes. And what that works out to be is that, depending on how long it takes runoff to start to occur, it's a storm that has a return frequency of 10 to 25 years. It's a very rare event. It's going to happen maybe 3 or 4 times every 100 years. And what we see in terms of measuring the amount of sediment that comes off that site, which likely takes every 5 minutes, is that we're losing less than a ton in a very worst case situation. But it also shows that there is some sediment coming off the turf site when you have these intense rainstorm events, and that could be a way for pesticides to move off site. One of the things that we're kind of interested in when we talk about the foliar layer is we'll all talk about returning clippings. That's the best management factor. It lowers our fertility requirement for turf grass. But what about potentially the return of clippings if we have a big event like that? You get this massive runoff. How many of those clippings are going to run off the site and end up in water supplies? Well, some of this work was published indirectly by Bruce Branham, something he put in the Carroll article, something the USDA published. It hasn't made it to the record of journal publication stage. But he looked at the mass of pesticides that were found in clippings and other particles as part of his runoff event. He found that the mass that he found in the clippings and particles was very small. And he basically said, we doubt that there's a higher mass of pesticides in runoff where clippings are returned. We tend to agree with that. And one of the reasons I'm pointing that out is because we've got data now where we're actually looking at clippings running off. This is that same picture I showed you. We have that massive runoff event. This is the flume. To give you an idea, there isn't a whole lot of clippings coming out of there. This is the amount of sediment that we're capturing every 5 minutes. And we're taking a fifth of a liter sample. Straining through a glass filter, and you can see that there's essentially no clippings within those samples. There was a little at 20 minutes, zooming in, there it is, 3 or 4 clippings, not even a measurable amount. So we tend to agree with Dr. Branham's earlier assessment that this really isn't a primary avenue that you're going to see pesticides moving into surface water supply. It's through clippings moving off the site, at least in the case with paintgrass. Something that is more of a concern to me personally, and this is somewhat opinion, it's something that I had to deal with face to face. That's people that are living next to bodies of water a lot of times don't manage their clippings correctly. What you see on the left here, I don't want to hit the wrong button here, but that's a massive dry clipping. It's a creek within Maryland. This is actually another set of clippings, very fresh clippings that we actually caught the individual in the act of putting clippings on the side of that particular creek. And you see clippings moving down.
That person dumped it.
Yeah, and he said, hi, how you doing? I said, oh, we're doing fine. And I put the picture of that. We have the best put it.
We get there by now.
No, the point I want to emphasize here is that there's a disconnect. People don't understand that pesticides can end up on foliage, okay? And they can actually persist on foliage for a very long time. Here's a good slide showing you some data that was done at Guelph University composting slide. How long was pesticides present within the foliage? And what you can see is that over a 10-week period, you got an 86% reduction. But you still have 14% of 2,4-D that was present in those clippings at the beginning, still present at the end of 10 weeks. So So the point I really want to make here is that, this is something that